Hello friends, welcome. This is Sarveshwar and today we would just learn how to compute adjusted R square from the given value of regular R square in a regression model. Okay, so for that purpose there are different formulas but the theme behind that is same. Here I have just taken a formula in terms of R square. There are some formula in terms of residual sum of square that is like 1 minus r square. If we remove, if we minus like 1 minus r square, it is nothing but it's RSS, residual sum of squares. So friends, today we learn I'm using R. We could also use data, views or Excel as well. For that purpose, we just need to calculate R square from the model. So I'm using R because it's simple and easy. So friends, first of all, what data I have for this purpose? Uh, Here I have the data for ACC stock in India and some volatility and spot and futures market, some variables I'm taking. Here friends, my purpose is just to explain what is R square. Why I have chosen these variables is not important here. Simply I am just taking a regression and just showing how to compute R square and adjusted R square. So friends here, I am just attaching the file just to make it more clear so it can read the data directly by column names. So these are the column names and now uh, I, I just want to run regression. Suppose I make a regression. This is my first regression I am running here where what I am doing here in first regression I am just regressing volatility of spot market on volatility of futures market, only one independent variable I'm including here with intercept. So if I compute that, this is my regression. What is summary of the result? The summary says it is highly significant. Volatility of futures is highly significant, and the R square and adjust R square also given here. So now I have mentioned here these are R square and adjust R square, but how to compute that? So friends, the formula I have taken here, it's very simple. This is the formula. It's from the literature. I'm not going to behind like how it has been computed. Simply I have taken the formula and what is intuition, I would just mention that simply 1 minus r square. R square is the R square, regular R square coming from the model. So here if I say the R square is 0.9272 is my R square, n is the number of observations. Already I know I have 733 observations here in the model. Seven total number of in your regression observations 733. So uh, and k is the number of independent regressor without intercept. So here I have only one regressor, the volatility of futures market, that's I included that only. So when I regress volatility of spot and futures, I find so when I use this formula here, 1 minus the regressor, then this value I can compute it's 0.9271, which is checked here. It's same. Now I just suppose what I do, I increase number of independent variables. So it is said when we increase the number of independent variable, R square would increase arbitrarily. It's very much sure that R square would increase. But would it be legitimate to increase the number of variables without any theoretical finding or like anything else? So what can we do here? We compute adjusted R square for the extra degree of freedom we are losing. So in this way, suppose I make another regression here, regression 2, where I include one more variable, trade quantity of the spot market. So and then summary of that. So now here my n is same, R square, new R square I'm getting here is 9276, is slightly higher as compared to earlier 9272. So now I want to compute this adjusted R square. Here friends, one thing, the k earlier it was 1. Now the k we have 2 because we have two variables. First is volatility futures market and second independent variable is trade quantity of spot market. Clear? So now when we run this formula, 1 minus r square 0.9276, which is here 9276, and then into 733 minus 1 divided by 733 minus number of independent variables 2 minus 1. This is 9274, checked, correct. In this way, similarly, when I have three variables and I want to compute that, I can do the same thing. It's again matched 9274. So here friends, overall r square is nothing but it's the adjustment for degrees of freedom we are using in the regression. Degree of freedom means uh, number of observations minus the estimates we have computed. Suppose it's so here friends we have 733 total number of observations, out of which we are estimating only one. So in first regression, only one is that volatility of futures market. This is our first estimate. That's why our degree of freedom would be 733 minus 1. It's 732. For second regression, 733 minus 2. For third, 733 minus 3. So see, so what do I want to say here? Degree of freedom means number of observations minus the parameters we have estimated other than intercepts. This is called here in this case degrees of freedom. So we are adjusting our new r square by adding new variable. We are adding a new variable in the independent model. Sorry, what I'm doing here in another new regression, what I'm as adding one more independent variable. It means I'm losing 1 degree of freedom. For that lost 1 degree of freedom, my r square is increasing arbitrarily. So I need to adjust that r square for this lost degree of freedom. So such kind of adjustment of degree of freedom is called adjusted r square. We are adjusting the r square for this lost degree of freedom. So friends, thank you for watching. I hope it was useful. Thank you.